Okay, now we're good. It has all the controls that it's supposed to. All right. So if you had signed in previously, sorry, I'm going to have to ask you to sign in one more time on the side just so we can get all of our attendance in for tonight. And we're going to be going through the Chapter 6 and Chapter 7 review that I had posted for you guys. So this way we can look through the types of problems and make sure everybody's good on how to go through all of those. Get my camera adjusted. And if you need me to stop at any point and go back through anything, please make sure that you let me know that, okay? All righty. And there we go. All right, so can everybody see okay? All right. Okay, so the first one's from chapter 6, was going through continuous and discrete variables. If you had to classify if something was discrete or if it was continuous, the reminder is that our discrete is what is countable, what is continuous is measurable. So if we're looking here at the first one, number 1, number of bottles of juice sold in a cafeteria, then that one would be discrete, okay, because it is countable. Let me see if I can get it a little bit more clear for you guys, okay? Give it just a second to autocorrect. Okay. And if you guys want to see it bigger on your screen of whatever it is that you're viewing on, if you, there should be a little menu at the top of Zoom where it has like gallery view, speaker view, or spotlight view. If you do speaker view or spotlight view, it should be able to put it as a bigger screen for you if that's helpful, okay? All right, so the number 2, the pressure of water coming out of a fire hose. Since this is not necessarily one particular number that's countable, but it is measurable because we're talking water pressure, that one would be continuous. The number of goals scored in a hockey game, that one is countable, so it would be discrete. The age of the oldest dog in a kennel. Now this is one that can be argued back and forth because if we're talking age, do we measure age or do we count age? Y'all can respond in chat or you can unmute your mic and chime in.
Count?
A lot of times we do. A lot of times we just say we count. But our counting of our age is a measure of how many days we've been on this earth, right? So that one could actually go either way. I would actually say it would be discrete because of we count. We don't do like that. We don't usually say like that somebody is 5 3/4. We don't say that somebody is, sometimes we do like 2.5 or something like with the halves, but we don't ever do those other in betweens. So if you had picked either one on this one, I would have counted that as correct. But because of the fact that it's age, and usually in our realm we would count that, we'd put that as discrete. Okay, but they may make the argument because it's measured in days that it would then be classified as continuous. So just be aware of the one where it says age. Okay. All right, and the next ones, you have some tables given to you. So given the table of probabilities, does it perform or is it a form of a probability distribution? The key for these is you want all of these probabilities, first of all, to add to 1. The second thing is you can never have a negative probability. So right away, right here, we see this negative one right here, and that automatically tells us, no, it's not going to be. Because even if it adds up to 1, because one of those probabilities was labeled as negative, then it can't happen, okay? Number 6, for this one, is it a probability distribution? Well, if we take all of our 0.02 or 0.07 or 0.22 or 0.27 and our 0.42, and we add them all up, our goal is for it to be 1. If it is 1, then it's yes, it is a probability distribution. If it is anything other than 1, it is not. And so when adding those up, you should end up equaling 1 right there. So because it does add up to 1, then we're going to have that one as yes, it is. Okay. Now the next couple tables, these are ones that they're going to be asking for either a mean or a standard deviation. Okay. So for these, we're going to be putting them into the calculator. We'll pull up my calculator right here. We're going to go to Stat. We're going to go to Edit. If we have any numbers in our calculator already, we're going to clear those out. We're going to enter our X values, our 2, our 5, our 9, our 11. On the other side, our 0.01, 0.06, 0.24, and our 0.69. Okay, so once everything is entered, our X's and our probabilities of our X's, we can go to Stat, Calc, and with our 1var stats here, this is where, because of the fact you've got 2 lists you're using, your first list is going to say L1. Your frequency list, which is all the probabilities, is going to be L2. And you're going to let it calculate. So our mean, our X bar, is 10.07. And our standard deviation is 1.75. So on this one, it specifically asked for the mean. So that's a 10.07. So that would be D on number 7. Okay. Now in the next one that we've got down here, it wants us to find the mean and the standard deviation. So I'm looking for both on this one. Same process for the number 8. I'm going to go Stat, Edit. I'm going to enter everything in. So I'd have my 0, 1, 2, 3, and 4. And on the other side, I'd have my 0.49, my 0.05, my 0.32, 0.07, and 0.07. I'm going to go to Stat, Calc, 1var stats, make sure I have L1 and also L2. Calculate, and it's going to hand me everything I need. So my X bar on this one is a 1.18, and my standard deviation 1.299. So when I'm looking for the mean, 1.18. Well, that's either going to be C or B. They both have that one. So then we look right here for our standard deviation. That one's 0.64. That's nowhere close. This one says 1.3. So it's going to be C for our number 8. Okay. Questions on the first page of the review?
Do we have access to the review?
Yes, this review has already been posted on Blackboard. It can easily be printed or pulled up. It is in a PDF format. And this video, as soon as we get done with our Zoom call tonight, it'll get posted as well, so you can go back and see the how-tos if I go a little fast on some of them, okay? All right, so the number 9 is similar. You have a table again. So any of these that have tables, we're going to Stat, Edit, and entering our table. Let's see, 0, 1, 2, 3, and 4. So that's the same there. So L2s, I'd clear out and put in my 0.02, 0.07, 0.22, 0.27, and 0.42. Okay, so then we're going to go to Stat, Calc, 1var stats, L1, L2. And once it runs everything, okay, and you get your mean, it's the first one with the X bar. Standard deviations, this one right here, and 1.04. So it specifically said standard deviation for that one, so I'm looking for the 1.04. And since the next number is an 8, we're going to round that on up to 1.05. So that's going to be C for number 9. Okay. Now, the next ones are some of the ones where you have to then start determining if something is binomial or if it's not. Okay. These are the ones where, and remember, anytime we're talking binomial, we're looking for checking our bins. If it is binomial, 2 choices, I independent, N a set number of trials, and S is your probability of success. It's going to be the same every time. So for our number 10, assume that male and female births are equally likely and that the birth of any child does not affect the probability of the gender of any other children. Find the probability of exactly 5 girls in 10 births. Okay, so what do we need for this one? Is it binomial? Chime in on chat or unmute your mic.
No.
Okay, well, let's check it. Okay, if we have binomial part and they're asking specifically on girls, we're either going to have a girl or we're not going to have a girl. So the binomial part is there. The independent, just because one birth ends up being a girl, does that determine a probability on the next one being higher or lower? No, because every time it's still going to be a 50-50, right? In a set number of times. Well, they're telling me I need 10 births. So yes, there's a set number that they're going to look at. And the probability of success. Well, if we're just talking about births, what is our probability? .50, right? So our set number of times that we're going to be doing this one is going to be 10. We're going to look for exactly 5. So on this one, I'm looking at a binomial PDF because it is a specific point of 5. So I'm going to go to second and VARs. Okay. And then I'm going to scroll down to where it says binomial PDF, and that's because it was an equals. All right. And now the numbers that are going in, the number of trials. Well, we're talking that we're needing 10 trials. So that's going to be our first value. The p-value, probability of success, that's going to be 0.5. The x-value, the number I want to look at, exactly 5. So these 3 numbers right here are going to be the numbers I'm going to plug in to figure out number 10. So I'm going to type in 10 for my trials, 0.5 for my probability, and that it's exactly 5 girls. Let it run, and it's 0.246. So it's going to end up being A on number 10. Questions on number 10? Okay. All right, so let's look at number 11. On number 11, according to government data, the probability that an adult was never in a museum is 15%. In a random survey of 10 adults, what is the probability that 2 or fewer were never in a museum? Okay, so my probability of never being in the museum, they actually already gave me of that 15%. So 0.15 is going to be my p-value. Then what they're asking me, because they said 10 adults, that's a fixed number. So that 10 adults is going to be my trials. And then what they're asking me to look at, it said 2 or fewer. So right there says that my x value I'm looking at has to be x less than or equal to 2. So now I'm doing a binomial instead of PDF because it's not an equals, it's a less than or equals. We're doing binomial CDF. Then we'd have our number of trials, our probability, and since it's less or equal, it's going to be the same number as what we use. I get to it in the same way that I got to my other one. So I'm going to go second. I'm going to go VARs. And I'm going to scroll down to binomial CDF. My trials were 10. My probability was 15%. My X value is going to be a 2. And I'm going to let it run. So 0.820 is where we end up for that one. So that's going to end up being D on number 11. Questions on the less than or equal to one? Okay. All right, so on number 12, assume that male and female births are equally likely, that the birth of any child does not affect the probability of the gender of any other children. Find the probability of at most 3 girls in 10 births. Okay, so for this one, our probability of success is going to be 50% again, because we're talking about birth and children. Find the probability of at most 3. When we talk about at most 3, it could be equal to 3, but I can't go over it. So does it or does it not mean the exact same as a less than or equal to? Corey, you are correct. Donna, you are correct. It does. If it says at most 3, I could be at 3, I could be at 2, I could be at 1. So I'm going to be less than or equal to 3. So my setup is once again going to be a less than or equal. So I'm going to do my binomial CDF. They told me 10 births, so that's going to be my first number. My probability is 0.5, and the number that I've got, because it's less or equal, is going to be 3. So I'd take this one and go in the calculator, second vars, scroll down, and I'd have my 10, 0.5, and 3. Let it run, and I'm at 0.1718. So it's going to end up being D on number 12. Okay. All right, so then on 13, it changes just a little bit, because here we have an at least problem, okay? So here on 13, can you guys see it? I went too far up, I think. Sorry, there we go. Okay, so 13, recent survey found 70% of all adults over 50 wear sunglasses for driving. In a random sample of 10 adults over 50, what is the probability at least 6 wear sunglasses? So I have 10 in my trial. My probability is 0.70, and at least 6. When we're talking about at least, I could be 6, I could be 7, I could be 8. So that means I'm going to be greater than or equal to 6. Now, with any of the greater than formulas, one of the things that we saw was that it is going to have a 1 minus in it. If it's greater than, or if it's greater than or equal to, those are going to have a 1 minus. So we're going to start by doing a 1 minus our binomial CDF. And now the only thing is you got to know if it is one that has the same number or one less. Who remembers? Correct. Correct. Christian, good job. It is. It's one less. So right here, we're going to end up putting in our 10, our 0.7, and then we're going to have one less than 6, so we're going to use 5. So we'd go into our calculator, and because we have the 1 minus part, I'm going to type that first one, minus, and then I'm going to do my second vars. I'm going to pull up my binomial CDF, my 10, my 0.7, and my 5. And let it run. So we end up with a 0.849. And so that one, let's see, would end up being our 0.85, which is going to be choice C on number 13. Okay. All right, questions so far? All righty. So now on number 14, this one has recent survey, 70% of the community favored building a health center in their neighborhood. If 14 citizens were chosen, find the probability that exactly 9 of them favor the building of health center. So right here, I have 14, I have 70%, and I have an exact. PDF or CDF? Good job, y'all. Yes, PDF, because it is a point, exactly 9. So on this one, we're going to do our binomial PDF. Our 14 is our trial number. Our 70% is our probability, and exactly 9, we're going to put a 9 right there and let it run. So to get that one, second vars, scroll down, binomial PDF, enter our 14, our 0.7, and our 9. And we get 0.1963. So that one should end up being C for number 14. Okay? All right, so that's how you use the binomial formulas, okay? Now, the other part with binomials that we touched on last week was knowing how to find the mean and knowing how to find the standard deviation. Your mean formula for anything that is binomial is just going to be n times p. Your standard deviation is going to be the square root of n times p times 1 minus p. Okay, so those are your two formulas for there. So if we look at number 15 on this one, recent survey that 73% of all adults over 50 wear sunglasses for driving. So again, we're in that same kind of binomial boat. In a random sample of 20, there's our fixed number. What's the mean and the standard deviation of those that wear sunglasses? So to find the mean, I just need n times p. So my n is my number I was dealing with, so that's my 20 adults. My probability is that 73%, so I'd take those two values and multiply them together. For the standard deviation, I'm going to have the square root of n, which is our 20, times our p-value, 0.73, times 1 minus the p-value, 0.73. And so all of that, and that's how I'm going to get these values. So I take my 20 times my 0.73, and I get 14.6 as my mean. So right now I'm either at B or C. My standard deviation, I take the square root, and then inside of it I'm going to have a 20 times a 0.73 times a 1 minus 0.73. Let it run, and I get 1.985. So right there, that's going to tell me that I need to have B as my answer. Okay? Questions on using the mean and the standard deviation with binomials? Okay. All right, so look at number 16 though, real quick before we get on to the next page. Right here, you have a quiz of 20 true or false questions. If the student guesses on each, what is the standard deviation of the number? It may seem like there's not enough information here, but you just need an N and you need a P. You've got an N, 20 questions. What's your p-value going to be with true or false questions? Yes, good job, Corey and Dada. Yes, 0.5, that's exactly right. So because of the fact that that 0.5, because it's true or false, that's your probability of success. So you've already got your N and your P. You'd follow the same formulas on 16 as you did on 15, okay? All right, so now the next ones are where we're using normal in our findings to get the probabilities, okay? So in 17, it says draw a normal curve with a mean of 160. Sorry, let me get where you can see it. Draw a normal curve with a mean of 160 and a standard deviation of 20. Label the mean and the inflection points. This is very similar to what we did with the empirical rule. The number that's going to be in the middle is going to be 160. Then with a standard deviation of 20, that means I got to go 20 above and 20 below. So that right there, 160 plus 20 more is going to be 180. Then 160 minus 20 is going to be my 140. So right there, we can go ahead and see that number 17, A is going to be what matches up right there. Okay. On number 18, they're giving you the picture and want you to determine the mean and the standard deviation. Well, looking right here at the middle, if -6 is what's marked as the very, very middle, then that guy right there is going to be our mean. Okay? Then, wherever your first lines are, the distance between that mean up to that first line, or the distance from the mean back to the first line, that distance is going to be your standard deviation. So the difference between -6 and -4 is -2 units. But because we're dealing in distance, we don't even deal with negative. We're just saying our standard deviation is going to be 2. So our mean would be -6. And our standard deviation is going to be 2. Questions on that one? Okay. I have a feeling some of you are going to have a race in it about who's going to get there to first for the chat on saying what the next answer is. All right. So the normal density curve is symmetric about which one? A, horizontal. B, a point located 1 standard deviation from the mean. C, its mean. D, an inflection point. Oh, y'all are on it. Man, you're fast tonight. Way to go, Kalina. You were first one on that one. All right, so yes, it's always symmetric about the mean. Good job. All right, so find the area under the standard normal curve to the left of. Okay, this is where we're getting into, now it's using the words normal or standard normal. Okay, here's your key parts. Right here, standard, normal, and they're giving you Z to start with. Okay, when you see this standard and normal, you know that your mean automatically 0 and your standard deviation automatically 1. Okay, now it says to the left of this guy right here. So if I sketch that out, and our mean's at 0, standard deviation's at 1, there's 1.5 right there. I got to go to the left of that guy. So that means what's my furthest left value I'm going to be using? Does anybody remember from last time? Correct, negative infinity. So to do, yes, and Corey, you're exactly right. And to do that negative infinity in the calculator, we're going to use the -1e99 to represent that negative infinity. Okay, so if we take our calculator and we go second vars, okay, second and vars, and we go to our normal, but we're doing CDF because this is a shaded area between some values. It's cumulative. Our lower value, -1e99. To get it, we do negative, we do a 1, we do second, we do our comma button, which pulls up our e, 99. Our upper is going to be this 1.5 that we have. And then automatically, because it said standard and normal, and we weren't given a mean and a standard deviation, it's automatically going to be 0 and 1. Let it run, and we get 0.93319. So that one will match up with choice B. Okay. Now the next one on number 21, this one says that we're going to be between these two values. And once again, we have our key part, standard normal. So because of that standard normal, our mean is 0, our standard deviation is 1. We will go to second vars, normal CDF. Now because I'm between these guys, my lower end is this -1.5. So he'll be first. My upper end is going to be my +2.5, so he'll be second. I'd have a 0, I'd have a 1, paste, let it run. I get 0.92698. So I'm looking to match that one up, so we should end up at 0.927, so match with choice A. Okay, questions? All right, looking at number 22, this one to the right of this particular one, standard normal again. So since we're going to the right, this guy is our lower. To the right, we're going to have to go up to infinity. So if I'm at negative 1.25, I'm shading this way, and I got to get to infinity. What will represent my infinity in the calculator? Yes, good job, Corey. 1E99, it's just the positive version. So when I go second in bars, I go to my normal CDF. I'm going to have my negative 1.25. My upper will be a 1. To get my E, I do second and the comma. Okay, and then I put my 99. I have a mean of 0, standard deviation of 1, let it run, 0.8943. Okay, and the next number was a 5, so it'll be 44. Choice D should match up for that answer on 22. Questions or concerns? I hear you, Christian. I hear you. You're going to get that next one. I see it. Okay. So now on 23, on. Okay. These are ones that are dealing with the normal CDF again, but the key with this one is that they don't say standard normal. It's just saying normally distributed, and then they're giving you a mean and a standard deviation, because right here it says normally distributed, but the word standard is not with normal. And they're giving you a mean, and they're giving you a standard deviation. So they're going to give you all the information you need. The only thing that changes now is that instead of using 0 and 1, we're using the mean and standard deviation they gave us. So I'm still going to go to second. I'm still going to go to VARS. I'm still going to pick normal CDF. And now right here, this one right here reads X less than 90. So if I'm doing me a little mini sketch here, my mean they told me was here at 80. Here's going to be my 90 somewhere on that side, and it says less than, so we're going to the left. So 90 is going to be my upper number. My lower number is going to be negative 1E99. So when I go second, VARS, I go to that normal CDF. My lower is my negative 1E99. My upper is going to be my 90. But now my mean is what they tell me in the problem. So this time I'm going to use 80. And my standard deviation, they told me the problem, which they told me was 8. I'll let it run. And I got 0.89435. So 0.894, and that would be 4. So it should end up at C. Okay. Questions on the differences between when it just says standard normal and then when you're given a mean and standard deviation? Okay. And then these literally line up exactly like the standard normal ones, except you're using the mean and you're using the standard deviation that they give you in the problem. Okay. On the other problems, we'd start with the word problem types, number 26, 27, and 28. I'm going to go ahead and flip over to number 27 so that we can go through this one together. You notice I'm leaving a couple for y'all to try out on your own just to make sure everything's all good, okay? All right, so on 27, length of time it takes college students to find a parking spot in the library parking lot follows a normal distribution, tells a mean of 6.5, standard deviation of 1. Find the probability that a randomly selected college student will find a parking spot in the library parking less than 6 minutes, okay? So my probability is that my X value is going to be less than 6. It told me normal, so I can go and use my normal CDF. Now, if I'm doing me a mini sketch right here, since they said, what was the mean? 6.5. and standard deviation of 1. So I would put that one at 7.5. I'll put that at 5.5. So my 6 that they're talking about is going to be about right here. And then it's less than 6, so I've got to be to the left. That means my other end down here is my negative infinity, or negative 1e99. Okay, and so with my normal CDF, my 4 numbers I'm going to have is a negative 1e99. Then I'm going to go up to the 6. Then the mean I'm going to use that they told me in the problem, 6.5. The standard deviation I'm going to use, they gave me in the problem, is 1. And I'm going to type that in and let it run. So I'm going to go to my calculator, second vars, normal CDF, negative 1, second comma E, 99, pick my 6, my 6.5, and my 1, let it go, and I got 0.308537. So if I go back up to match, right there's going to be my 4 decimal places, should match up with choice B. Okay. Now the difference in number 28 is on this one, it's asking, it says we're going to be between 2 values. Let's see, follows, we have a mean of 6.5, standard deviation of 1 still. So the biggest difference here is that the setup for 28, on my curve, I'm at, here's a 5, and here's a 7.5, and I want that area in between them, okay? So when I'm setting this one up, I would have probability that my x is going to fall between 5 and 7.5. I would use normal CDF, and my values would go from 5 to 7.5. My mean is 6.5. Standard deviation is 1. Then I go to my calculator. Second vars, normal CDF, 5, 7.5. Then I do 6.5 as my mean. My 1 is my standard deviation. Let it run. 0.77453. And so right here, 0.7745. And I'd have choice D for number 28. All right, that's your review. So y'all talk to me, or how are we doing? Okay, so here's the deal with everything that we just went over on this particular review. Okay, yes, and I totally understand that, Cara. I know a lot of it's just practice. The good thing is that you have your time to practice. The good news is you can have your notes because you're going to have this right in front of you. Your test is going to look like this. Okay, everything we went over tonight is going to be the same stuff that you're going to see on your test. Basically, it's this review with new numbers. Okay, so as you go back and you watch this video again and you go through the problems maybe with it, or you sit down and practice with it a little bit more, it's going to make a whole lot more sense. Putting that calculator in front of you is going to help as well. And hopefully you saw the link for the calculator app so that you guys can have that on your computer as well. Unfortunately, if you have a Chromebook, they don't have one released yet because they're doing a pilot program right now for the Chromebook version. But if you have a PC or a Mac, you should be able to download that TI calculator from the link that I put up on Blackboard. Okay. If you have not read the announcements on Blackboard, please make sure that you do that because there are some important things under assignments and under announcements. So if you have not caught up on all of the announcements and assignments, please make sure you read all of those before the end of your time while you're sitting kind of for your designated class time. Okay. Does anybody else have any other questions or comments for me or for the class or anything? The test will be due on the 9th. Okay. That's when it's supposed to be due, and it should actually have released already. Maybe I'm not sure. Not sure what time it is. Let me check and see, because it was supposed to post at. Okay, so it'll post in 20 minutes. I already have it ready to go, so it'll post like at 7 o'clock. Sure, Colleen, no problem. I'm going to work with you guys as much as possible and make it so that it's a whole lot easier. The test itself is a PDF because of the fact that I can't stand it when it tries to convert it into Blackboard. So that is my gift to you, that you can take your time on it, pull it up, either on your computer or anything like that. Because here's the thing, and I know that this is a hard enough spot already for many of you. And the biggest thing is I just need to know that you can do it. So we're on honor code on this, that you're just not going to, do somebody else's and turn it in. And I think you guys get more out of it doing it that way as well, where you can sit down, take your time, go back through your notes. I think you remember more of the content that we've gone over when we do that. Okay. So just do me that favor and make sure that you are really taking a look at the review before you sit down to do the test. Okay. And I had told you before that if we need to go back through and if you need a redo on something, just let me know and we'll work that out however we need to. Okay. Anybody else got any other questions?
I'm scanning and sending my test to you, the 4-5, Miss
Okay.
Reed. So hopefully it'll come to you soon. Right
All
now.
right.
Okay.
Not a
Thank
problem.
you.
Oh, and if anybody else needs a kind of a scan option with your phone, CAM scanner, CAMSCANNER, CAM scanner. If you put that one in like to look for an app, it's a really good free one. Just deny where it says professional and sign up. You can get a free the free version of it, and it can save stuff directly to your Google Drive. And it makes beautiful PDFs of anything that you are trying to take a picture of, whether it's handwritten out of a book or anything else like that. And I know that could be a very useful one. Okay, let's see what other questions. Of course, Christian, you know it. Madison. Yes, please do, Madison. If you get stuck on anything, if you guys are having trouble on anything, please email me. Any direct questions that you have, I'll be happy to answer. And I am still dropping the lowest test grade at the end of the semester. Okay? Anybody else got any other questions? Okay. Well, I have a favor to ask before everybody logs off here. I need to see everyone's beautiful faces at least once before you go. Yay, I can see faces. All right, I miss you guys. I really do. All right. Corey, that's okay if you don't have a camera. I get it. Hey, Donna. Hey, Jessica. Y'all just take care of yourselves, take care of your family. Do the best you can in the situation that we have. Hey, Angie. So, y'all take care of you. Anything else that I can do for you, you let me know, and I will do my best to make it happen, okay? All right. Y'all take care of yourselves, and I will see you on Thursday, same time. Bye.